If you're someone like me who struggles with making UI elements in Photoshop, watch this video. I'm going to show you how to make scalable UI elements using Shadergraph. A few months ago, Unity released a sample for Shadergraph that has a whole bunch of UGUI SDFs, so that way you can create UI elements on the fly. To get it, go to your package manager, scroll down until you find Shadergraph. For any URP project, you should already have it. Click on it, and then over on the side where it says description, go over to samples, and then scroll down from there. There's a bunch of different samples, but the one we're going to use is a UGUI Shaders. So import that into your project. The shader we're going to be making is fairly complicated, but don't worry, I'll walk you through every step, and I'll have the subgraphs as well as the main shader graph available to download. So that way, if you don't feel like going through the process of actually doing it yourself, you can just follow it on there, and it's easy enough, it'll work. So first thing we're actually going to do is we're going to make the shader graph. So go to create, go down to Shadergraph, URP, and then you want to find the canvas shader graph. This is going to be how we make our UGUI element work on our UI canvas. So we're just going to name that UI status bar and create it and open it up. So here's our blank shader graph. I'm going to walk you through making one of the subgraphs first and show you exactly how to do it. And then for the other subgraphs, what I'm just going to do is show you what they contain so you can copy them or you can use the download. So first thing we want is we want to get a rotate node. Then we want to take the out of this rotate node and plug it into the UV of a polar coordinate node. This is so we can get that circular cutoff when we have our bars. So we're going to now feed this into a split, and we want to just take the green channel or the Y channel. So we're going to take that green channel, and then what we're going to do is we're going to plug that into an add node and add 0.5. This just makes it so the values between 0 and 1, 0 being the start of the gradient and 1 being the end of the gradient. So that's all that add node is doing. But you can see it's at the bottom. We don't want that. So if we change the rotation to degrees and turn it to 180, now it's at the top. So this lets us scan from the top around. You can also rotate this to any angle you want. It's just where the start and end of our circle will be. So now we put this into a histogram scan as the gradient. And then now you can see that if I change the contrast to 1, it creates a hard line between them. And if I modify the position, that changes what our fill, our radial fill, is going to be. So I'm just going to set this to 0.75 for the time being. And then next, we're going to make a circle. So this is a sine distance function, which is a mathematical way of representing a circle. Luckily, the Unity team built all of this into the sample set, so you can just pull it directly, and it's much easier to work with than writing them yourself. So now we're going to take the smooth from our scan and multiply it by the stroke of the circle, and that gives us that. If we multiply by the fill, we get the actual circle cut out, but we want the stroke so that way it's hollow inside. You can also plug in the SDF, which gives you more of a smooth version. It's a number representing how close or far from the circle you are, but we're going to use the stroke. And then we're going to plug this into our base color, and this is what we get out of it. We have a circle that we can change the position on, and by doing that, we now have it filled however much we want. So we can modify that value at runtime to represent our health or our mana or anything that way. And that's how we do it. So I'm going to highlight it all, right click, go to convert to, and then subgraph. And then I'm going to name it radial indicator underscore test, just so we have it somewhere that I can identify it. And once that's made, we can double click on the node, and now we go into our subgraph. So we want to make a few properties here. So we want to get a float that's going to be our fill amount, and this is what we're scanning by. We want another float that's going to be our stroke thickness. So this is how thick that line is going to be. And then one last float that's going to be our size. I'm just quickly going to clean things up here just so that way it's a little bit less messy and I can better explain what we're actually looking at. So now what we're going to do is we're going to take the fill amount value and we're going to plug that in as our position in our histogram scan. Then what we're going to do is we're going to take our size and our stroke thickness, and we're going to feed those into the size and stroke thickness respectively. The size I'm just going to default to about 0.5, and the stroke thickness to say 0.1. And then the fill amount, let's also put it at 0.25. Now that's really all there is to this subgraph. This is a pretty simple one. We can also just look at our output here. We don't need that vector 4. So what I can do is I'm just going to shuffle the order here, click on the vector 4 and remove it. And then I'm changing the out vector 1 to just out. This float is going to be what we're actually going to use later on. Now we can close this and go back to our main shader graph. You'll notice it is trying to preview it in 3D, which for this purpose isn't really great. That's something that's really easy to fix. If we just go back to the actual subgraph and we change it from preview 3D to preview 2D, now when we go to the main graph again after saving it, it should now preview in 2D. This just makes it a lot easier for us to see what we're doing as we go through. So I can adjust these values and it will play with everything. Now I did actually mess something up right at this point that I am going to cover in just a sec there. And that's this Boolean here, stroke thickness relative. We want to make sure this is turned off basically everywhere throughout all of these subgraphs. It just messes with the thickness of the stroke depending on the size of the item. The next subgraph is going to be one with rounded tips. So it's the same type of radial indicator, but we have rounded tips. The base of it is the exact same. It's literally the same thing as the first radial indicator. So you can see those are all the same values. However, down below it gets a little bit more complicated. So I am going to make this available. I'm just going to quickly explain briefly how this works. But if you don't understand it fully, I'd say download it and play with it. So we take in the stroke thickness, the size, and the fill amount, and we're going to divide the stroke thickness by 2 and 4, the size by 2, subtract them, multiply, set it as a vector 2, and put it as 2 options for tiling and offset for 2 circles. And then for the second circle, we're offsetting it by 2 pi radians multiplied by the fill amount. This is representative of 360 degrees multiplied by our fill, so the second circle ends up where it should be. I also just forgot to put that stroke thickness in there. But that's how we get the positioning of these 2 circles. So once they're in place, we need to actually put them together. So we dump them into an add node with that original one and together, and now we have those rounded ones. I also use this to create the softer ones so we can create some subtle shading effect. So there are some nodes here to do some math and get a new circle, and we take the SDF and we're going to inverse lerp it to get a kind of blurred version. We have it saturated so that way it doesn't overshoot 1 or 0. And then we're going to output it as either the SDF or the negative SDF. So we have 3 values here. We have the stroke, which is the top one, the SDF, which is going to be that white background, and the inverse SDF, which is the black background. So those are just some helpful values to have. Next is a subgraph that makes our bars flash if they're low. So we get the 1 minus of each of our input values, we subtract them, we check that it's greater or equal to 0. Then what we want is we want to take the input value and the 1 minus of it and feed it into a branch node with that comparison as the predicate. So this returns 0 if it's less than, but returns the 1 minus value if it's true. We then have our flash speed value. This just controls how fast the flashing happens, and it's scaled by the closer it is to 0. So that gets fed into a sine time node. And then we also have a vector 2 that is the x component being the input value and the y component being 1. We plug this into a remap node. Finally, this output gets multiplied by another branch that just checks that the input is greater than 0. This just stops it from flashing really fast if it undershoots or overshoots a little tiny bit. And then the last thing we're going to do is we're going to do another comparison between the input and the threshold and make sure that the input, if the input is greater, it just returns 1. So it stays a solid color and it doesn't do anything. And then finally, this just all goes out to our float output, and then we have our flash. The last subgraph that we're going to use is going to be a ring one. So we have the stroke thickness and the size, we're feeding it into a circle. We also have another circle we create by dividing the thickness by 2 and subtracting it from the original size. So we feed that in, we want to make sure stroke thickness relative is off, and we're basically doing the same thing as we did for the rounded indicator. Except this time we're just doing the whole ring, we're not having the ends, so it's a little bit simpler, and we're outputting the same 3 values, stroke, SDF, and the inverse SDF. Alright, let's get started on making our actual shader graph. So we want a float that's going to be our stroke thickness. And then we're also going to want to make some floats for our different status values. And I name them health 01, stamina 01, mana 01, so that way I know they need to be normalized between 0 and 1. I'm also creating a value called brightness 01. This you can ignore for now. It's for a little extra something later on that I'll show you that isn't the actual status bar, but something else you can do with this sample set. So what we're actually going to do now is we're going to take the health 01 value, we're going to pull that in, and what we want to do is we want to pull that and the stroke thickness, and we're going to take both those values and feed them into one of our radial indicators, specifically the rounded one, just because I find it looks a little bit better. We're going to put that into the fill amount and the stroke thickness respectively. So I'm just setting the health 01 value to be a slider. It just makes it easier for me when I'm working in the inspector to show what it does later. But you can set it however you want if you want to leave it default, but I find sliders are quite useful. Then we plug in the stroke thickness as well. So we also need to set the size of this. So I'm just setting it to 0.8 for now. It's not showing anything because our stroke thickness was set to 0, but if I set it to 0.1, you can see it's there. That size being 0.8 is relative to the entire image. So 0.8, it's 80% of the image in total height. So now we're going to take the inverse SDF value and feed it into a power node. This just helps strengthen the edges of it a little bit. Next thing that we're going to add is going to be a multiply node. So we're going to put that into here. And what we're going to do is we're going to add a color. So we're going to call it health color. Yes, I am Canadian. I spell color with a U. Get over it. So we're going to do that for each of our values. So we have health, stamina, and mana. So we're going to take the health color. We're going to take the stroke and multiply it by our health color. So right now nothing's showing up because the health color is still black. But if I set it to be a red color here, you can see now our indicator has taken on that red value. So I'm just setting the colors for the other ones quickly so that way we have them set up already. For now, I'm just going to start out pretty basic with this, but it's going to get a bit more complicated later on. So then the next thing after we have these multiplied is we're going to multiply it again. So we're going to multiply the power node by this. So it just creates kind of a shadow around the edges, and it creates that faux shadow effect to give it a little bit more depth. So I'm just going to move those over a little bit. And now what we're going to do is we're going to add the threshold flash. So this one, we have our input and our threshold values. So feed in the input there, and then we're going to take the output of this and multiply it by our output of the power and color nodes. So now if it's below that certain threshold, it will start flashing. So that's really it. I'm just going to do all this process over again for the stamina. So I'm going to duplicate them and plug in the stamina for the appropriate values. And once I have that done, you'll be able to see that now we have a green version of the same thing. So to move forward, now we want to add our health and our stamina together. You can see they're the same size. So we're kind of getting a yellow color there. So if we go here and we reduce the size to 0.6, now the green ring is smaller than the red one. So they're separated from each other and everything is good that way. Now we're going to do it again for mana. So do that all over again and create it for the mana. I'm going to set the mana size to 0.4, plug in all of its appropriate values. And then what we're going to do is we're going to add this to our added health and stamina. So we're just going to keep adding them together so that way we have all three bars in one image. Now we have that there. You can also see a little bit of the flashing going on from the mana being low, but if I change these values, you can see it dynamically updates. So I just cleaned things up a bit, and now if I zoom in, you can see what the flashing effect from the threshold flash is. So if I make it smaller, it'll flash a little bit faster. If I make it really small, it should flash quite fast. And if it's above 0.25, it shouldn't flash at all. So you can see it stopped flashing there. So I did have to go back and add the properties for the threshold and flash speed to it. So they weren't there originally. I already covered it in the video. It's back there. So we're going to make two properties in the shader graph here. That's the flash speed and the flash threshold. And we're just going to feed that into our threshold flash subgraph. I'm just moving them up to the top so it's a bit easier, but these now can be dynamically changed in the project. So that way, if you want it to flash when it's lower than that or higher than that, and you want it to flash faster, slower, you can change those values yourself and set them. So I'm just going to speed through adding that for the stamina and mana. And then I'm just going to do a little bit of cleanup to make it neat. It's good to clean the things up as you go. It just makes it easier to work with. And then the next thing we're going to work on is making the colors a little bit more detailed. So while having colors like this, it works, but we can get something a little bit cooler and you can really create anything you want from this. So instead of just having our base color values, what we're going to do is we're going to use kind of a pattern or a texture to do it. So we want to add a time node here, and then we want to add a rotate. This rotate's just going to rotate it around the center to give it a bit of movement, so that way we have that. Then we're going to add an animated clouds pattern. This is also part of the sample package. So we're going to plug the time into the rotation of our rotate node, then plug that into the UV of the animated clouds node. So with that plugged into the UV, you can now see that our animated clouds are spinning. And then we also want to change these values to be 0 for our color 1 and 1 for our color 2. This just makes it so the values are between 0 and 1. And then the speed, I'm going to set that to 0.1, so it just gives it kind of that mixing foggy effect. So then I'm just going to hide some of this stuff, make it a little bit cleaner. And then what we're going to do from there is we're going to take the out of our animated clouds. So grab that and put it into a multiply node. And I'm just going to multiply it by a float. You can just drag, if it's giving you that vector 3 option, you can drag that out and set it to a float and it'll just multiply the whole thing by one value. So I'm going to set that to 5 just to make it a little bit stronger. Next, we're going to make some new colors. So we want to make a secondary color for our health, stamina, and mana values. I'm just going to pick something that's a little bit of a lighter version, but you can use different colors if you want. This is entirely up to you, and it's all modifiable at runtime in the editor. So if you wanted to represent something different, you can also do that. So with these colors, these are going to be values that we're going to lerp between. So I'm just going to set them quickly. So for health, a little red, stamina, lighter green, and for mana, let's try purple just to throw some variety in there. So now what we're going to do is we're going to get rid of our color up here. We're going to replace it with a lerp. So I'll show you just an example with the red here. If we set the T value to this cloud texture, and then we set our A and B to our health color and our health secondary color, you can see what pops out now is a kind of cloud texture with that applied to it. So we have that little bit of variety in there. And what we're going to do is we're going to do this for each of our colors. So, and then we're going to plug it into the multiply node where our color was before. I'm just going to fast forward through me doing this for the other two colors here. I'm a little bit anal about my placement, so it takes me a minute or two to do these things. So fast forward is going to be my friend here. But once this is all ready, now we should have that little bit of extra detail being applied. And if I go and look at it here, you can see a little bit of shininess kind of turning throughout. If I up the intensity of our clouds here to a higher number, you can see even more so that this is kind of glowing a little bit, or it has some lighter sections to it that are spinning around. So I'm just going to set that back. Now we're almost done with the actual status bar part here. We're not quite there. The last thing we need to do is we need to basically create an alpha mask. So what I'm going to do is I'm going to take our radial indicator subgraphs. I'm going to move them over a little bit. And we want to pull out the stroke from each of them and put them into an add node. So we just want to add all the strokes together for our 3 different circles. So we're going to have the first ones and then another add for the second one. Or sorry, the third one. And this creates our mask that we're going to use later on. So now that we have those, I'm just going to clean up again. Now that it's cleaned up, we're just going to select everything and we're going to group it, and we're going to rename this to status bars, so that way we have it all grouped together and we can just pull out our color and our alpha mask values. Next, we're going to go back to our scene view and we want to actually use this. So the first thing we're going to do is we're going to create a material from the shader. So just right click, create material, and we're going to name it status bar matte. Just something that's easy to know. The next thing is we need to actually display this somehow. So we're going to go create and we're going to make a UI. We're going to go to image. So this is going to be shown as an image. I'm just going to rename this to status bar. And then I can apply this material here and you can see, well, nothing at the moment is happening. And that's because we never actually applied this as our color or as our alpha value. So I just swapped over here. And now if we go back to our UI status bar, we want to set the color to the base color, and then we want to save it. And now that that's saved, you can see it is outputting the image that we're shown in the preview. The nice thing about doing your UI in this way is that it's infinitely scalable. So if I go over and I mess with some of the height and width of the image, you can see that it's scaling and there's no pixelation. It's going to stay perfectly crisp no matter what size or aspect ratio it is, because it's being generated on the fly using math rather than being an actual image that is either stretched or compressed. If I go back and I take our alpha mask value from the bottom and I feed it into the alpha property of the shader, and then I save that, now when I go back to the game view, you can see it's also applied that alpha there. So now we can see through, we don't have that big black box anymore. Now back to the shader, what we're going to work on next is going to be our background. So we're going to do this just beneath our main color status bars. And what we're going to do is we're going to put in one of our ring subgraphs that we made earlier. So we're going to put that in there, and then we're going to get our stroke thickness property. We're going to feed that into our ring test stroke thickness parameter, and we're going to repeat this 4 times or 3 times, so we have a total of 4. So once we have 4 of them there, then what we're going to do is add together all the inverse SDFs from these. So if we add them together, you can see that when I put them there, nothing actually really changes, and that's because they're the same size. So what I want to do is I want to change this top one to be 0.9, so it's a little bit bigger than our biggest status bar. Then, don't want to click on that. Set this next one to 0.7, so it's between the size of our biggest and our medium status bar. Then the bottom 2, we're going to add those together. The same thing, we're going to have to adjust the size of these. So then we want it to be 0.5, and then the smallest one to be 0.3. Then we're just going to add all of these together again. So add our top 2 and our bottom 2 here. And now we have these kind of concentric rings here. And they're the SDFs, so they're a little bit smooth and they have that kind of shaded effect on them. Now we're going to do this all over again. So we're going to create another 4 rings. But this time, instead of using the stroke thickness directly, what we're going to do is we're going to put the stroke thickness down. We're going to put it into a multiply node. And what we're going to do is we're going to multiply that by 2. And we're going to plug that into the stroke thickness. So this just makes them a little bit thicker. And then I'm also going to once again set the size. And we're going to duplicate these 4 times. Once those are set, we're going to do the same thing as before. We need to adjust the size. This time we're not going to do right in between the values. This time I'm going to do 0.85, 0.65, then 0.45, and finally 0.25. These are numbers that you'll have to play around with if you're making something else. But they're all there, and you just have to kind of toy around with it until you get the look you want. Again, we're going to add all these together, so we get these concentric ring patterns again. So we're going to do that for the top 2 and the bottom 2. And then what we're going to do is we're going to add those 2 add nodes together again. And now we should have 2 separate sets of concentric rings, ones that they don't quite stack with each other. They're a little bit offset. So now we're going to take the top set here. And what we're going to do is we're going to feed that into a subtract node. And then we're going to subtract the bottom set from the top set. So now we have these rings where there is black areas and white areas, and there's a little bit of shading. So this was just the way that I found was most effective for creating a fake shaded effect in it. But there are definitely different ways to do it. And if you play around with these numbers, you can create whatever effect you want. So if I change the strength of this multiply, you can see it affects the size of the bottom set. So play around with this as much as you want to create the effect you want to. I'm just going to keep this as 2, and I'm going to start doing some cleanup so that way this is a little bit more condensed and a little easier to work with. So next we're going to add those segments that I showed at the beginning. So we're going to add a circle segment node here. And what we want to do is we don't want this to rotate. You maybe do for your effect, but for the one I'm creating, I don't want any rotation. So what I want to do is I want to take the rotation value there where it says linear time. I just want to put in a float and make it set to 0. So that way this doesn't rotate anymore at all. And I'm going to set the segments to 12. So it kind of is like a clock almost. And then you can play with the spacing. So I'm setting it to 0.95 and the blur to 0.75. And then from that, what we want to do is we want to move it around, and we're going to take the lines output. We're going to multiply it just by about 5, just to increase the strength of them a little bit. And just move these out of the way. So now what we're going to do is we're going to take the output of this multiply node, and we're going to subtract it from our circles. So we're adding another subtract, and we're subtracting the multiply from the circles. So yeah, that's set up there, and you can see there's kind of some cuts out of the circle shape there. So now I want to add a color, and I want to add a background color, and I'm also going to add a second one as the background secondary color. So I'll get those added in there. I think for this one, what I'm going to do is I'm going to just kind of make it like a gold look and pick something kind of orangey yellow in the middle there, and that'll be our kind of gold color. And then something a little bit darker for the secondary. Now what we're going to do is we're going to take these and feed it into a lerp, if I can spell. So the subtract is going to go into the T, and then our background color and our secondary color are going to go into A and B. Now it doesn't quite look right yet, and that's because this is actually oversaturated. So the values are above 1 or below 0 in some spots. And that's because we were doing addition and subtraction in a bunch of different places. So how we want to fix this is we want to output this to a saturate node. This basically normalizes the color or stops it from overstepping. And now that we have that, you can see it looks a little bit more like what it should. It's not overstepping the colors, and you're not getting any weird artifacts. So with that, we now have our color for our background ready. We're just going to group this, name it background. And with that, we have our background completed. So we're just going to readjust this. And next we're going to actually apply this background color. So for the time being, I'm going to remove our alpha mask from being set to the alpha. We're not actually going to use it that way yet. So the next thing that I'm going to do is I'm going to take the output of what was our alpha mask, and I'm going to put that over into a 1- node, so we get the opposite of it, and then put that into a saturate, so that way it's between 0 and 1. And then from that saturate, we're going to multiply. We're going to multiply this by the colors we just made. So what this does is it just cuts out the area where our status bars are. Not that you would actually see through them, but I think it just helps a little bit. I found that it made it look a little bit better when I had it this way. So I'm going to do it like this. Again, play around with it however you want. So then we're going to take our other color in an add node and add them together. And now we have those. We can apply it as our base color. But again, you can see now we're back to being a big square where the background is shown. So let's add a circle. And let's make the size of it 0.9. So it's as big as our largest circle that we made in our background. You can also make it a little bit bigger if you want a bit more visibility. And that edge max value controls the blurring. So we can set this as our alpha, and now there's that cutout around it. So I think 0.9 is a better look for it, or maybe 0.925. So I set that, and then I just hide this, and that's what's going to be our alpha value. Since this is always going to be a circle, we can just leave that as our alpha value. So now let's save it and jump back over to Unity, and you can see now we have our circle there. So I'm just going to do some quick adjustments to the image. I'm going to make it a little bit bigger so it's easier to see for the video, as well as I'm going to play with some of the colors just to get a little bit more of what I'm looking for out of it. And I think like that is going to look a lot better. Just create a bit more contrast, have the darker colors in the middle. So I think that looks pretty good for our basic look here. So what we're going to do is jump back in and create our center effect, which is going to be a sun and moon eclipse type look. So this is going to show depending on whether or not the player is in a bright area or a dark area, but you can do whatever you want in the middle here. This is just something I was using for a game I was working on, so I'll show you how to make the sun and moon effect. So grab a linear time node and then a multiply node. You're going to leave this one as multiply by 2. So we're going to plug in the loop into the a value of our multiply, and then we're going to have a second multiply, which is going to be multiplied by 0.5. You can also set it to negative 0.5, positive. This is going to affect the direction that our circle segments that I'll show you here are going to rotate. So if I plug it into the rotation, it looks a little bit fast, but when we play around with it, you can adjust that, and you can change these multiply values to make it slower or faster, or you can adjust the linear time speed as well. So you can play with this stuff as much as you want to create the effect you're looking for. I'm also going to adjust the segments value here. So instead of being 18, let's set it down to 5. Let's play with the spacing a little bit and maybe adjust the blur somewhat. So now I have this first one here. I'm going to duplicate it, and instead for the rotation, I'm going to plug in just the plain loop time, so it's a little bit slower. I'm going to set this one to maybe 12 segments, and then down here for this one, I'm going to create a third copy, and I'm going to plug in that other multiply node that's now times negative 0.5. So plug that in. I'm also going to change the segments here to be something like 18. And with that set there, now we have our 3 different circle nodes. This is going to be creating some kind of light beams coming out of the sun. So what we want to do is we want to take the triangles value from each of these. So I'm just going to move this up a little bit and take the triangles out of one and add it to the triangles of the next one. And then we're going to do the same thing for the last one as well. We're going to add it. So as I'm adding them, you can see it's kind of, they're stacking, and because they're not at the same speed, it creates kind of a shimmering type of look. So I think that creates the effect that I'm looking for a shining sun. So with that, we can still play with more of the spacing. You can do it however you want, but I think this is a good looking effect as is.
The next thing that we're going to make is we're going to make the actual circles for the inside of the sun, as well as something to blur the edges out. So we're going to create a circle here. We're going to set the size of this circle to 0.01, and then the edge max we're going to change to 0.25. So this creates kind of a blurred shape here, and this is what we want to use for blurring out our edges. Next, we're going to create another circle here. And in this one, we're going to do something similar. We're going to set the size to 0.1, our edge min to negative 0.1, and then our edge max to 0.1. So now we have those 2 circles set up, and what we're going to do is we're going to take the fill of the first one, and we're going to multiply it by the output of our add node. So that way our circle sparkle effect is going to be limited to the area where that faded circle is. So just going to move this around a little bit. And then we're going to take the output of our second circle, and we're just going to multiply it by a number to make it a little bit stronger. I'm just going to go with 5 for this one, but you can adjust this as you feel necessary. So then we have these 2 different ones. From our second one, we're going to take a add node and add it to our sparkles. So this creates kind of our shining sun effect. So that should be all there is to this part here. So we can select it all, group it, and rename it to sun, and then clean it up a bit. Next, we're going to make our moon. So we're going to take that brightness 01 value I added earlier. We're going to pump it into a multiply. We're going to change this to be something like -0.4. This just offsets it a little bit so it doesn't show up when the value is 0.5, it shows up in the right spot rather than being completely off the screen. So then we're going to feed this into a rotate node, and we're going to leave this as radians for now. We are going to change the center of the rotate to be 0, 0, so it's rotating from the bottom left corner rather than the very center of the image. And then we're going to feed this into the UV of another circle node. So we're going to change this down to about 0.15. And then now, if I actually change that brightness value, what you'll see is that that circle kind of moves and turns in and out of the center. So it's only going to be visible when it's in the center, but it creates kind of the eclipse effect I'm looking for. Rather than just moving directly straight line into it, it curves a little bit and it just adds a little bit more to the effect. So we're going to take that and do a 1-. So that way we have everything on the outside being white and everything inside the circle being black. And as per usual, we're just going to do a little bit of quick cleanup before we move on to our eclipse effect. So to get started with the eclipse, what we want to do is we want to create a new property. We want a color. We're going to make it our sun color. And then we're going to have a second one that's going to be our moon color. So this is what's going to change depending on the state that it's in. So that way we can have a little bit of variety between when we're in one state or the other. So next we're going to add in a multiply node. I'm going to move that up a little bit, and we're going to output our sun and multiply it by our moon. So you can see this is in the full eclipse state. There's now a big black dot in the middle obscuring the center of the sun. So then we're going to take our brightness 01 value, multiply or divide it by 0.25. You could also multiply it by 4. I don't know why I chose divide here, but it doesn't really matter. And then what we're going to do is we're going to move that over, and we're also going to put this brightness value into a 1- node. So just tidy these up quickly, and then what we're going to do is we're going to get a lerp node. So we're going to grab this lerp, and we're going to plug in the divided brightness 01 value into a saturate, and then feed that into our T. So once we have that set up, the next thing we want is we're going to want to grab our two colors, and we're going to put those in there. And just for how it's set up, you want the sun color to go into B and the moon color into A. Depending on how you have your values set up, it might be flipped. But that's just depending on what you're saying this brightness value represents. So now this will lerp between those two values. I'm just going to quickly set some colors. So for the moon color, let's make it kind of a purple-y hue, and then for the sun, we'll go for a bright yellow. So we have that. And then what we want to do is we want to multiply this. So we're going to get a multiply node, and we're going to multiply that by our combined sun and moon look. So that way now it has the color applied to it. So you can see if I change the brightness value, the moon moves out of the way and the color changes to be more appropriate to what's shining through, whether it's the moon blocking the sun or the sun itself. So now we're also going to take the output of our sun node, and we're going to put that into the A value of a lerp, and then the B value is going to be that second multiply also from the sun node. It's getting a little bit kind of spaghetti nodes here, but then we're feeding in the 1- as the T value. It's a bit of a pain to see. I just keep it all tight so I can keep it organized, but the shader will be available for you to look at. You can expand it, play with it, and see what's actually going on here. So this is basically just changing the alpha mask from being solid, a solid circle with some feathered edges, to being the shiny sun effect we want. So this is just so that way we don't get too much shininess when it's in the fully eclipsed state. So we'll group this and we'll call that eclipse, and then just move that up a little bit. And now we're pretty much done. We just need to add everything together. So now we need to do two things. We need to create our alpha mask, and we also need to create our color. So if I grab the color part from the eclipse here and I put it into an add node, I'm going to add together it with our status bars. Then what we're going to do is we're going to take this output and we're going to put it into a saturate node. That saturate node, again, it just stops things from going past 1. So it disables HDR, but it can also disable color overflow. We're going to put this into the add node for our background color. So now you can see that the eclipse is there, but it doesn't quite look right because you're actually seeing the background through it. So that is why we also need to create our mask value like we do down here, where we cut out the areas of the background. So what I'm going to do is I'm going to add an add here. I'm going to feed one of the values back to the original mask that we were doing, and then the other one I'm going to put up to the mask for our eclipse value. So now that we have that, you can see in the center there, it's now black. So this just creates that effect that we're looking for, and it will be black as it moves in or out. So we're not seeing the background color through it, and we don't have to worry about adding the background black to it. And that's all there is to this. I know I say that that's all, but it was a lot. But if we save this and hop back over to our game view, you can now see here we have that sun, moon, eclipse going. If I actually jump into play mode and then I just play with some of the values that we have here, so you can see that now our status bars are there. The mana one is glowing because it's at or below 0.25. And if I go to our material and I adjust the fill amounts for our health 01 value, you can see it dynamically updates, and they all stay independent of each other. So you have all three of these values, and this is encoded entirely on the GPU, so there's no CPU resources being used for this. There's also no memory resources for the texture being allocated. So since it's drawing directly from the GPU, this is a fairly performant way to do it. I can also adjust the brightness value here, and you can see that we get that kind of eclipse effect. Next thing we're going to do is we're going to make a compass shader. So we're going to go over to Shadergraph, a canvas Shadergraph, and we're going to name this UI compass. So I lost the first part of the recording here, but I'm going to show you what the values are. So we have a float for our size, a vector2 for our offset, defaulted to 0.4 on Y. Size, we're going to default this to be about 0.2. Then we have a background color. This will try to match to our status bar, so we'll set this to kind of a gold color and then a darker version. And then we also have a gem color and a gem secondary color. I'm going to go for maybe an amethyst for this, but you can pick any colors you want. So then now that we have all these flat values set up, what we want to do is we want to add a constant. We want this set to pi. We're going to plug it into a rotate node set to radians. And then we're going to take that and put it into the UV of a tiling and offset node. We're going to duplicate this tiling and offset 3 times, so we have 3 versions of it. So I'm just going to create a couple more there. And then what we're going to do is we're just going to minimize these so we can make them a little bit tighter. And then we're going to take our offset vector2 that we created, and we're going to add that in here. And this part, it's a little bit complicated, but we want to put this into a subtract node. We want to subtract 0 from X and 0.015 from Y. And then what we're going to do is we're going to feed the offset into another subtract node, and again 0 on X and 0.0275 on Y. So these values, I had to play around with them a lot to get them to look right. You can play with them yourself to create the effect that you want to. We're going to feed the first subtract into the second tiling and offsets offset node, and the second subtract into the third one, and then we're just going to feed the direct offset value without the subtractions into the first tiling and offsets offset node. So it's a little bit convoluted here, but trust me, you'll get the effect at the end. So the next thing that we're going to work on is we're going to take the first subtract node and we're going to feed that also into the third tiling and offset. So the second and third tiling and offset will both get from the first subtract node, and then we're going to make a fourth tiling and offset for the third one. Even I am getting confused by this, and I have a working example sitting right beside me, and it still gets a little bit confusing. So now we have that set up. I seriously confused myself at this point, so I deleted this node without realizing it was actually correct. Don't worry, I'll add it back in a minute or two, but I'm going to keep working forward with the actual effect. So what we're going to do is we're going to take the output of the first tiling and offset node, and we're going to put that into a triangle SDF. So I'm going to go and I'm going to put this into a triangle here, and we want that as the UV. And then what we want to do is we're going to set this triangle down, just move this stuff out of the way, and then take our size value, plug that in for the size of the triangle, and then just zoom in a little bit here. Next thing we're going to do is we're going to change the corner radius value. So we're going to set that to about 0.2, 0.25 to get the kind of rounded edges we want. And then we're also going to uncheck stroke thickness relative. We're going to create another triangle node here, and we're going to feed that into the second tiling and offset. And then for this one, we're going to again set the corner radius to something like 0.25, 0.025 for this one. And then uncheck stroke thickness relative. Going to take our size value here, put it into a subtract node, and we're going to subtract 0.1. So then now that we have that subtract, we're going to take this subtracted value and we're going to feed it into the size of our second triangle here. So that way it's going to be a little bit smaller than the first one. Then we're going to take this subtract and put it into an add, and add 0.05. So this is just to get the sizing right for what we want. And we're going to get a third triangle node, feed this into the third tiling and offset, and set that added value to our size and our corner radius again to 0.025. Then we'll set the stroke thickness to 0.05 and again uncheck stroke thickness relative. So now that we have those three triangles, this is probably around where I'm going to realize I made a mistake. So I'm going to change that so that way the two triangles there are going to feed into the second tiling and offset node. And then the third tiling and offset node is going to feed into the UV of a circle segments node. So this one, you can see it's now centered where we have our triangles. It is spinning. I don't want that effect, so we're just going to set the rotation as a float for 0. And then we're going to change the segments here to 3. And then we need to adjust the spacing here. I'm setting it to 0.95 and the blur to probably something a little bit higher, maybe 0.25. So now that we have that, we're almost ready to actually start making our compass point here. So we're going to take the fill of our first triangle node here, and we're going to subtract the fill of the second triangle from it. So now we've got kind of a triangle with a cutout in the middle. So once we have that ready, we're going to take the SDF stroke of the first one. We're going to put it into a lerp node as the T value. And then we're going to set the edges of the lerp to some values that I kind of just had to find. So I'm setting it to 0.7 and then 5.05, or even you can just use 5 here. And that creates kind of the effect that I want for the gem to look a bit more three-dimensional. So collapse those, move them off to the side there. And then what we're going to do is we're going to take the output of this lerp node, we're going to feed it into a multiply, and then we're going to multiply it by the background color. So this gets us kind of the gold look we want for our background. And then what we're going to do again is we're going to take this into another multiply node, and we're going to multiply it by the subtracted output from above. So this creates kind of our cutout, so we have that shape. Now we're going to take the output of that lerp we just made and feed it into a different multiply. This multiply, we're going to add our gem color here. So this is how we get that 3D effect I was saying for the gem. Then what we're going to do is we're going to take the stroke of our third triangle here, we're going to put this into another multiply node. And we're also going to multiply this by the secondary gem color. So this kind of creates an edge around it. So once we have that there, what we're going to do is we're going to take the output of our primary gem color and add it to the output of our secondary gem color. So this kind of just overlays the colors onto each other. Then the next thing we're going to do here is we're going to take the lines output from our circle segment node. And we're going to multiply this also by the secondary color of our gem. So now we have some purple lines that go out, and they should be centered right on the middle of the gem there. Then we're going to multiply this again by just a float to increase the strength of it a little bit. I'm going to set it to 2, 3 maybe. And then now what we're going to do is we're going to take these values and we're going to add them together so that we have kind of this little bit of an overlay. It's kind of hard to see here, but it does just add a little bit extra to the effect. Next up, we're going to take the output of that add node, and we're going to take it and we're going to multiply it by the fill of the first triangle. So by multiplying it by this fill, it cuts out our shapes. That way we don't have anything past the edges we want. So now we have that shape cut out. And we also need to apply a alpha mask, so that way we have something to block what we don't want to see. So the alpha mask for this one, luckily, is quite simple. I'm just going to put the fill of that same triangle there, and then I'm just going to create some extra nodes here to get it out of the way. But it's nice and easy. This just blocks out everything but what we want to see, and then we can take the color of our background and the color of our gem and add them together. So I made a mistake here, and I didn't use the right triangle during my multiplication here. I used the first one and not the second one. This made it so that way the gem was being cut to the same size as the background, and rather than the hole that was cut out of it. So if I just change that to the second one and now I zoom in here, you can see our gem looks properly cut out there to fit in that slot in the middle. So now that that works, we can just plug that into our base color here, and then we're going to do some quick cleanup, and I'll bring you back to Unity. I apologize for how long this video is. It's quite the complicated shader, and I didn't really realize that when I first made it, so I'm trying to speed through what I can. Sorry that the editing is not perfect, but this should work and you should be able to use it in your project. So now we're going to jump back to the editor, and we're going to create a material based off of this UI compass. So this material, we're just going to call it UI compass mat 1. We want to do that so that way if we want to create more than one, if you want to have stacked compasses, you can. And then we're going to duplicate our status bar material, name this compass 1. And then we want to change the material to be the UI compass material. So you can see now it's appearing over top of it. So if we drag it above it in the hierarchy, it's now behind. You have to play with the draw order a little bit. If we change the size, you can see it makes it bigger, but it is actually getting cut off. That's because how these samples work is they're based off the total size of the image. So if I want to make it bigger, I have to actually increase the size of the image itself. So now with it being like that, of course, because of how I have it set up, the anchor is set to the bottom corner. So I have to play with these values a little bit, and how I actually did that, it won't perfectly work, but you can play with the sizing, you can play with the offset to get the effect that you're looking for. So once you have this set up, we're just going to feed it into a super simple script to control the rotation of these values. So I just have something called a status bar controller here, and it has a really easy script that I'll show you in a sec there. You just want to make sure you set your values. So set the main compass to 1, and if you create another one, set the secondary compass as that second image. And then we also need to set our material as the status bar material, and if I go into play here, you want to make sure you actually set the status bar material to the correct one, because I have it set to the version that I was copying from, not the version I made in this video. So that's why it's not updating, but I'll quickly jump to when it's actually the right one. So now I set it to actually be the right one, but you can see it doesn't quite work right. As I'm rotating, it's not rotating the way that we would expect it to. And this is because of what I was saying before with the anchoring. So you can't use an anchor that's set to a corner, since this needs to rotate about the center of itself. Rotating it while it's anchored on the corner will rotate the image on that corner.
So what we're going to do is we're going to clear those values, and we're going to change this a little bit. So we're going to set the anchor position to the center. First, we're going to actually make it a child of our status bar. So that way it's in the exact same spot, and we set the anchor to the middle, and then we're going to unparent it from that status bar component. So now with that, it should be in the right spot, and as it rotates, you can see it will spin around the proper axis, and it'll actually rotate around our status bar here. So now if I go back into play mode, once this loads, you should see that now this compass is going to point north, or whatever vector3 dot forward is, the absolute vector for the world direction. So that's always going to point in the same direction, and this creates our nice little compass effect. Now we can also do this with a secondary one to track an object, which I'll show you in a sec, but I'm also going to show you the scripts of how I did this. The controller for this is super easy. We just have our player controller. We also have two rect transforms, one for each of our compasses, and a public material. This material, we're setting the O1 values for each of our stats appropriately. I actually screwed up, and you can see for mana, I'm setting health. And then for the rotation, we're also setting the rotation equal to a quaternion.euler, where the Z is the direction from our player control. So how this is doing it is we have these are just our values up here for our stats, but this is the part where we have our rotation. So the compass main direction is equal to compass rotation relative to vector3.forward. So that is the absolute one. If I go down to compass rotation, this is simply just the vector3 signed angle with the from direction, the transform forward of the player, and we're rotating it about the up axis. So it's getting the rotation between them, and that's how it's setting the rotation of this compass. So that's one of the really nice uses for the vector3.signed angle. If I go back up top to our secondary compass, you'll see what I'm doing is I'm creating a new vector from the target position to the player. So I'm getting a direction vector, but I only want the X and Z components. We want to flatten this on Y, so Y is equal to 0. If we don't, you get some weird jumping because we're comparing it from a not flat vector to a two-dimensional vector. So finally, if I just set those values and set a target for our player, now when I go into play mode here, you can see I just set our status bar values to go up and down with time. But now we have our two compasses, one that points in the absolute direction of north and another one that points at a target. So as I'm moving through the scene here, you can see this one points towards this green X here. As I move around it, you'll see that our compass is going to stay pointing towards it. So this is a really easy way, and you can duplicate this again if you want to have a third type of target, or if you want to use this for anything else. This is just a really easy way of tracking something in the world by using these vectors and flattening them. So that's really all there is to this. I hope you enjoyed making this. I know it was a long, complicated video, but it's really easy. It runs entirely on the GPU, and if you resize it to any size, it will maintain the exact same fidelity. That's the nice thing about having these, is they're generated mathematically. So if I have a really big version here, you can see it has the exact same clarity as if I were to duplicate it and create a smaller version. So even though they're two different sizes, they both have the exact same look. They're the same sharpness. There's no pixelation on the edges between them like you would get by using an actual bitmap UI element. There's a link in the description with the subshaders and the shader graph, so that way you can just take this and plug it into your project and use it. If you like this video, please leave a like, comment, let me know, and thank you for watching.